Hey guys, today we are going to graph sine and cosine functions. I think you're going to find that they're very similar to each other and they create wave functions. So a couple of vocabulary words you need to know. The period of the function is how often it repeats, and the amplitude of the function is how high it goes. So the sine and the cosine function, both just the parent functions, have an amplitude of 1. They go up to 1, down to -1, in a period of 2 pi. They repeat every 2 pi. The difference between the sine graph and the cosine graph is where they begin. And the sine graph begins at 0, 0. At pi over 2, it's at 1, and then back pi 0, 3 pi over 2, -1, and 2 pi 0. So there is one period of the sine function. And now we're going to do that again on the other side of 0. So we're just going to do the mirror image here. So there's a sine function. The cosine function doesn't go through 0, 0. It goes through 0, 1. So as the sine function goes what I call up, down, down, up, the cosine function goes down, down, up, up. And there is one period of the cosine function. So what you're seeing here is 2 periods of the sine function and 2 periods of the cosine function. If you're given y equals a sine b theta or y equals a cosine b theta, where theta is in radians, make sure your calculator is in radians, then the amplitude is always positive, absolute value of a, because height is positive. And then the period is 2 pi over the absolute value of b. Period will also be positive. So looking at your graph, or your equation here, your amplitude is going to be the number in front. And then our period is going to be 2 pi over 2, which is just pi. Notice where b is and a is. Amplitude for problem 2 is 3/2. Period is 2 pi divided by 1/3, which is 2 pi times 3, which is 6 pi. So that means it's a long way away in order to find a complete period of that function. So taking a look at our next page, we have a page of graphs, but we're going to identify the amplitude and period first for each one, and then we're going to use our calculator to graph them. So our amplitude is 4, period is 2 pi. Amplitude is 1. 2 pi divided by 1/2 is 2 pi times 2, so 4 pi. Sorry, you can't see that. And 1/2 and 2 pi divided by 3 and 5, and we've already done 2 pi divided by 1/3 was 6 pi. And amplitude is 1, and 2 divided by 3/4 is 2 times 4/3, so that's 8 pi over 3. And then 5/2 and 2 pi, and 3 and 2 pi over 2, and 2 and 2 pi times 2/3 is 4 pi over 3. Now, to make this pretty simple for all of us, we see that our graphs are all labeled the same. So I want you to go to y equals and clear, and I want you to go to your window. And we're going to graph from -2 pi to 2 pi, and our scale is pi over 4. Because if you look at your graph, every pi over 4 has a bar or a line. So we're going to do that. And then we're going from -5 to 5 with a scale of 1. So now we're going to y equals, and we're going to graph number 3, 4 sine theta, and just type in x for theta. And graph. Our height is 4. It's going to go up to 4 and down to -4. And this kind of shows you where you need to graph your function. So we know 0, 0. And at pi over 2, we're up at 4 and 0. Anytime you have a period of 2 pi, it makes it that much easier. Now with the period of 4 pi, we should expect it to be a little bit flatter. So cosine of 1/2 x. Notice where it crosses. Notice the height. X-intercepts are easy to plot here. So we have 0, 1, and then 1, 2, 3, 4. 1, 2, 3, 4. And then the next 4 go to -1. And then our next one, 1/2 cosine 3x. There's a lot going on here. So we're just going to do our best. Our height's 1. So we're going to do our best. And for number 6, 5 sine 1/3 x. So 5 means it goes all the way down. 6x is spread all the way out, so you don't see a whole lot of your graph there. I'll just count to see where those end up. And for number 7, cosine 3/4 x. Touches at the pi's. 1, 2, and almost to 3. And number 8, 5 halves sine theta. Again, that period of 2 pi really helps. So all you have to do here is go up and down to 2 1/2. And it's sine, so it goes through 0, 0. And then just connect your dots. So the 2 pi graphs are nice. And then for number 9, 3 sine 2x. This one is easy for you to plot the x-intercepts. And then you're going to alternate going up and down to 3. I think I messed that one up already. I did. One, 2, 3, 4, 5, 6, 7. So there's some, I'm going to white out some of them here in just a minute. Did pretty good on the positive side. The negative side, I didn't do too good. There we go. And our last one, y equals 2 cosine 3/2 x. And this is another one with a weird period of 4 pi over 3. So we're just going to do our best and go up and down to 2. So we have here, and let's see, 1, 2, 3, 4, 1, 2, 3, 4. And then this one is going down to 2 here. Trying to kind of fill in the blanks. 1, 2, 3, 4. And then 1, 2, 3, 4, and down. So we're going to go up to 2. here, and then down, and then here, and down, and up, and down, and there. Do the best you can on those graphs. All right, guys, this concludes our section on sine and cosine graphs. It concludes our section in our chapter on trig. Let me know if you have any questions. I hope you have a great day.